Okay, this is section 1.2 in your textbook. We're looking at multiplication and division of mixed numbers. So we have a problem here on page 20 in your textbook. So we'd like to read it very nice and loud. Yeah, Josh.
Whitney? Oh.
Yeah.
Learn about the math. Vero is using small boxes to transfer cans of soup from the 2 2/3 of the large boxes in the kitchen of the food shelter to the basement. A large box holds 1.5 times as many cans as a small box. Once the transfer is complete, there are a total of 7 3/4 small boxes full of cans in the basement.
Yeah, how many?
Oh, how many small boxes of cans were moved to the basement? How many large boxes would hold all the cans that are now in the basement?
Okay, the one trick about this question is that there was already some small boxes in the basement. Okay, so it's a little bit confusing in that regard because you think you're just transferring the stuff from large boxes to small boxes, but there was already some small boxes in the basement that are full of cans. Okay, because it tells us there's 7 3/4 small boxes in the basement, which is more than how much cans we have in the large boxes upstairs. So we know because of that fact that in the basement there was already some cans that were down there. It says how many small boxes of cans were moved to the basement. So we know that there's 2/3 large boxes that are being transferred to the basement. And we know that each large box is 1.5 times a small box. So therefore, if we want to know how many cans were moved into small boxes from the large boxes, we need to take the number of large boxes and multiply it by how many small boxes fit in a large box. Right? So we need to take 2 2/3 and multiply it by 1.5. Okay, that'll tell us how many small boxes have now been moved to the basement. Any questions about that? So we have a simple multiplication here. 2 2/3. This is what's upstairs in large boxes. Okay, and we want to know how many small boxes that's going to fill. Because downstairs there's only small boxes. So if we have 2 2/3 and we know 1.5 small boxes fits in a large box, we're going to multiply these two. So the first step is we want to convert to an irregular fraction. So 2 times 3 is 6 plus 2 is 8. Times 3 over 2. Now when we deal with multiplication of fractions, it's pretty straightforward. We multiply the numerators and we multiply the denominators. We don't have to worry about finding a common denominator. So in a sense, in this case, multiplication is a little easier than addition and subtraction. So here we have 8 times 3, which is 24, over 6. We're left with 4. Okay? So the 2 2/3 large boxes makes up 4 little boxes in the basement. Does that make sense? Okay, the next part says, how many large boxes would hold all the cans that are now in the basement? So it tells us that there's 7 3/4 small boxes now full in the basement. Well, if we want to know how many large boxes go into this 7 3/4 small boxes, we need to divide this amount by the number of large boxes. Alright, so that's where this equation comes from. 7 3/4 divided by 1 1/2. So we're going to convert this to a regular fraction. 7 times 4 is 28 plus 3 is 31 over 4 divided by 3 over 2. Now we don't have to worry about finding a common denominator, but we do have to do one thing. Does anybody remember when we divide fractions? Philippe? Yeah, we multiply by the reciprocal. So another way you can think of it is cross multiply. I hate to say that though because people use that term wrong quite often. So let's stick with multiply by the reciprocal. It's one extra step, but it might help some clarity a bit later. So 31 times 2 is 62 over 12. And this will give us 5 and 1/6. This can be converted to 31 over 6, which is equal to 5 and 1/6. So all the cans in the basement right now that are stored in little boxes, if we then moved all those to big boxes, 7 3/4 small boxes would fit in 5 and 1/6 large boxes. Okay, any questions? All right, moving right along. So Daniel, we're going to move over here. So the next question says, determine the volume of this cube. So we know the equation for volume of a cube is what? We know that volume is equal to what? Michael.
Length times width times height.
Good. Length times width times height. So in this particular equation, because it's a cube, we know that the length, the width, and the height are all the same. And it's given as 2 3/4. So we know that our volume is this equation. Again, converting to regular fractions, we have 11 over 4. And then we multiply all 3 across the numerator and all 3 across the denominator. And now to convert this to a mixed number, the first time we've seen one that's a little bit difficult, you might not know in your head. I showed you that trick, so you're just going to put that on your calculator. 1331 divided by 64, and what do you get?
20, but decimal.
20 what?
I forget everything.
Joseph.
So I have the actual fraction.
Okay, give me the decimal.
7/9.
20.79?
Yeah. That's not wrong.
Exactly?
Well, there's a bunch of numbers after.
79 what?
796,875.
Okay, so remember the trick is the whole number is going to be the whole number here. And then you can take that decimal value and multiply it by the denominator. So what is that? Yeah?
51.
So you're left with 51 over 64.
Yeah.
That's it. Okay? So that little trick in this particular case worked well, right? You didn't have to think too much. It was automatic. There's also a little button on your calculator, okay? It's good to learn how to use it if you have it. It looks like this. It can convert a decimal into a fraction automatically for you. Okay, so get familiar with that button, especially when we're working with fractions. You can also punch in these numbers as is into your calculator. Okay, so you would press 11 ABC over 4. Okay, so that would be 11 over 4 multiplied by 11 ABC over 4 multiplied by 11. You can put that right in your calculator and it'll give you something probably that looks like this. Or I think that it gives you this symbol.
Yeah.
Okay, which just means over. So you should realize that that represents this. Okay? Any questions there? All right, the last question, example 5. Example 5, page 26. Somebody to read quickly. Joshua, over here. Page 26, number 5. At the top. Joshua? Sorry.
Joseph.
Joseph, my bad. Devon's father?
Bond's father is installing new wood flooring. He bought boards that are 10 feet long, 3/4 inches thick, and 11.24 inches wide. For the number of boards Devon's father will need for a 10-foot by 16.5-foot room.
Okay, so there's our boards that he bought, and it says to fill a room that's 10 feet by 16.5 feet. So the width fits perfectly, or the length, sorry, the length fits perfectly. We have a room like this, it's 10 feet long. So we only have to worry about the width, which is 11 and 24ths. We don't have to worry about the thickness at all, right? Because it can be as thick as you want. It's still gonna just be lying on the floor. So it tells us the width of the room is 16.5 feet. So we just need to take that total width and divide it by the width of the board. That'll tell us how many boards go into 16.5. So 16.5 divided by 11/24. We're going to convert to mixed fraction. So 33 over 2. We're going to reciprocal this. We want to multiply. We're going to multiply these out. We're going to get, here, this is one note you can notice. If you see a fraction like this and you don't want to deal with big numbers, but you realize they can divide in right away, you can see 2 goes into 12. These can cancel. 24 and 2, they can cancel to 12 and 1. Okay? Likewise, you can say 11 goes into 33, 3 times. Okay, so you're just left with 12 and 1, that's right, 3 and 1, yep, so you're left with 36. Okay, so 3 times 12 is 36, and 1 times 1 is 1, so you're left with 36 over 1, which is 36, okay? So that's a good skill to realize, that you can make cancellations before. Otherwise, you could have multiplied this straight out and then reduced at the end if you wanted to. But this you're going to have to know later, especially later on in this course in grade 10. You're going to have to be aware of this skill when you have things multiplying, simplifying them right away. Otherwise, it just gets too long. Okay, and that's the end of 1.2. Carlson?
I was just making my page.
Okay. Right, you can stop it. All right, when we get back.